We have 3 group by and 2 times join. We further optimized it to 2 group by and 2 times joins, and we further came down to 1 group by and 1 join. Many of you commented that they really appreciate the SQL breakdown structure. You people want me to share some more queries using SQL breakdown structure. So here it is. In this video, I will solve one medium level SQL query from data Lemur, and it's from the snapshot interview question, sending versus opening snaps. You can pause the video, go through the SQL question and continue to read the question till the time you are very clear about it. Okay, so I will start with the usual thing. What I will do is I will write some of the steps we use in SQL breakdown structure, derive table and derive columns, and revisit the output. So these are the steps at the high level we use in SQL breakdown structure. In this video, we'll also leverage SQL Pattern System and the maze approach to build our understanding. Let's start with the question. Assume you are given a table with information on Snapchat users, including their ages and time spent sending and opening snaps. So I have some information about the Snapchat users. I have never personally used Snapchat. So if it is something very specific to the application, I may find it difficult. In that case, if it would have been my interview question, I would have asked the interviewer, or I would have known Snapchat before going into the interview. Okay. Write a query to obtain a breakdown of the time spent sending versus opening snaps as a percentage of total time spent on these activities grouped by age group. Round the percentage to 2 decimal places. Notes: calculate the following percentage: time spent divided by time spent plus time opening divided by time spent. To avoid integer division in percentage, multiply by 100.0 and not 100. Okay, so let's go through the first step, which is identifying the keyword. So if I read here, the question is time spent sending versus opening snaps. So obviously there is some comparison happening here. Then I read that percentage of total time. So this means that I have to do some aggregation, because percentage is like here in the notes also they have mentioned the calculation that you have to divide by something. So some aggregation will happen here. I'm sure percentage includes aggregation. Now in the next phrase, they have mentioned that it should be grouped by age group. So it clearly tells me that I have to do group by age group, or whatever is the column corresponding to age group, right? They also mentioned that you round it to 2 digits. So I have to do some number manipulation. And there's one more information they have mentioned, that you multiply it by 100.0 decimal thing. So another number manipulation. So this all the keywords in the question. It's a really small question. We'll go through the table. So we have one activities table and we have one age breakdown table. 2 tables we have. Okay, and there are some columns mentioned here, and input, and then this is the output. Okay, so I am clear with the question, what is required. Almost all the lines I have put here in the keywords, but it is good for understanding. So let's move to step 2, which is derive table. So select star from activities. Now as part of derive tables, what I mentioned earlier is that you have to consider only the columns which are actually required. So in the output, if I see, I just need age bucket, send percentage and open percentage. So if I see here, this activities table has too many columns. I will need activity type, because I have to compare sending versus opening. So comparison, I may have to apply a where condition here maybe, right? We'll see. So select activity type, definitely I have to do. And then time spent, because that's what they are saying, that total time I have to do aggregation on time spent. So this tells me that I have to keep time spent column as well. And then I have to use user ID also, because I see user ID is a common column between the two tables. So user ID and user ID, I have to join these two. Alright, so I think I'm good here with activities table. Let's quickly go to the second table, which is age breakdown. And here we'll see we just have two columns, user ID and age bucket. So I will be using both the columns here. And if I understand it correctly, the age group, what they want to say is actually the age bucket column here, right? If there are such confusions during your interview, you have to ask these questions. So age group, when they say here grouped by age group, I understood that they mean grouped by age bucket column basically. All right. So let's go to step 3. Now with practice, all these things you have to do in your mind, and it will become very quick. Trust me. Like I generally don't follow all these steps. It just happens automatically in my mind because I have practiced it multiple times. So if I see the output, age bucket column is already there. So age bucket is not a derived column, but send percentage and open percentage. Send percentage and open percentage. So I have two derived columns also. And as I said earlier, that some of the common reasons what I have observed of derived columns are aggregate columns, number manipulation, string manipulation, right? So our case statements. So we already know that we have to do group by something. So this will come as a combination of aggregation and number manipulation, right? We don't know yet, but yeah, that's the whole idea. And then the step 4 is always revisit the output. So we will, once we have the query and the output, we will revisit the output and the solution to see if we can further optimize it. So let's start with the SQL query now. So what I will do is, first step is create the derived table. Now I can already think of 2-3 ways in which I can solve this SQL problem. There is a comparison aggregation. I can also use it using a where condition. So I calculate information about the sending snaps, and then I calculate information about opening snaps. Then I combine them together. So there are multiple ways I can think about it, and we'll go through all those options, right? So the very first step, what I will do is I will go through a very simple solution, whichever I can think of right away, and then we'll see. So what I will do is and since people prefer to create CTEs, what I will do is with send snap as, and this is my table, and then open snap as. So what I'm doing here is I'm creating 2 CTs right now, right? Where I will I'll calculate the information about sending snap, and then I'll calculate the information about opening snap, and then I'll just merge the data set to find whatever information I need. So here what I will do is select activities. Let me call it as DT1. And then I have to join using the next derived table. You don't have to create it. With practice, it should automatically come to you, right? On dt1 dot user id equal to dt2 dot user id. So what I am doing right now is I need user id and I need age bucket and this. And since this is for the send snap, I will add a filter here where activity type equal to open. This is for the send, so equal to send, right? So right now all I am doing here is I'm just joining these 2 derived tables which I created in step 2 on the basis of user ID and let me get the required column. So I will take dt1.userid. I will also dt2.age bucket, and then I will do sum of dt1.time spent as send time from. And when I am doing aggregation, I have to put all the non-aggregate columns in group by. So I will do group by. Right. So is this clear? I hope this is clear to you. I have not done anything. It may look like a lot of rows, but so far I have not done anything. All I have done is I have two derived tables. I don't really have created, but I just created it for simplicity. So I have two derived tables. I have done a join on these two derived tables, and then I have done a group by. So all I need three columns: user ID, age bucket, and total time spent. And then I have, since I'm doing a sum, all the non-aggregate columns will come in the group by. So I will just copy this and I will put it here. The same logic, only change will be here. Instead of send, I will put the filter condition as open, right? And let me change the name also. That's it. So I already have all the information about the open snap. I already have all the information about the send snap. Now all I have to do is merge these. So what I will do is right now select star from, and then I will use send snap. Let me give alias as SS, initials of the, and then I will do inner join open snap OS on OS dot user ID equal to SS dot user ID. So, and the columns I need here is OS dot age bucket, OS dot open time, SS dot send time. Okay, for now I'll just hold here. I'll run the code and see if everything is working. So I do see the output, age bucket, open time, send time. But our output expect send percentage and open percentage. So what I will do here is sum of open time, sum of send time. Also, I'll bring send time first because the send time as per the output is the second column. Yep. Group by OS dot age bucket. I will again run this query just to see the output. So I am getting the output. Now to convert it into percentage, what I will do now is I will use sum of send time plus open time, and this I will call as send percentage, here as open percentage. Okay, I'm just doing an aggregation. That's it, nothing else. Now there are some number manipulations what they have mentioned, right? Round to 2 digits, multiply by 100.0. So this is exactly what I'm going to do here. I'm going to use round function here, and or shall I show you the output? So let me just multiply it by 100.0 and I will show you the output now. So the output looks like this, right? And that's why they have mentioned in the question that you should round it to 2 digits. So this number manipulation is required. So what I will do is round, comma 2 to make it to only 2 decimal digits, comma 2, and I'll run. You see here, 2 decimal digits, percentage, everything looks fine to me, right? You can pause the video, go through the SQL question and just rephrase it whatever I have done. So in step 1, we identify the keywords. Step 2, created the derived table. Step 3, identified the derived columns. And step 4 is still pending. So we created a derived table for first table and we created another derived table for age breakdown table. Now in the CT, we are just joining these tables. This is CT for send. So we have applied a filter for send, like here we mentioned. Similarly, we created another CT for open. So it's exactly the same code copied again, only this time the filter is open. So we created one CT for open data, another CT for send data, and we did a join on the basis of user ID. And then we grouped by age bucket. We did a sum into 100 divided by total. And that's how we calculate the percentage. 2 number manipulation actions were required to multiply by 100.0, not 100, and round to 2 digits. So we have done that. And this is the output we are getting. So I'll just submit this output. This looks good to me. I'll submit it. We'll see if the output is correct or not. Okay, so the answer is expected. It is matching. But there are some obvious improvements I can do, right? So we'll revisit the output now. This output is correct. If you'll write this, nobody can say that the output is wrong and it's not right. Your output is matching, your query is correct, it is running fine. But if I would have been your interviewer, the first thing I would have asked you is, can you optimize this, right? And I can definitely optimize it because some of the clear cases I can see here is, we are using group by here, we are using group by here, and then we are using group by here. So at 3 places, we are using group by. Also, what we are doing is, we are doing a join here, we are doing a join here. So same table we are joining 2 times, although the filter conditions are different, right? So I do see we can further improve it. So let's call it as iteration 1. The answer is right. If you write this, nobody will say that you have written the wrong query or you are getting the wrong output. Output is right, query is right. Just that, to find whether you have in-depth knowledge and can you dive deep into SQL query, an interviewer can ask you that, can you further optimize it? And I already mentioned that, okay, I see multiple group by in this query. Can I further optimize it? So yeah, so let's start with another iteration for the same query. Let's call it iteration 2. And what I will do is, I will just copy everything, right? Because I'm going to further optimize this SQL query only. So let me just comment it down, because on this platform, it runs only one query, not multiple queries. So this is my query and I have to further optimize it. So what I know is, in derived table, I need user ID because I have to join these 2 derived tables using user ID. But going forward in the output, there is no requirement for user ID, right? It just need age bucket and send percentage and open percentage. So one very obvious improvement of what I can do is, once the joins are done, I will not select the user ID now, because the purpose of user ID is done. This column is no more required. So I'll just remove this column from select and the group by. Similarly here also, I'll just remove it. I don't need user ID column to go beyond this point. Now, why did I do it? Because as soon as I removed user ID, my aggregations are now happening at the level of age bucket. It is not happening at user ID comma age bucket. My groups are now made using age bucket only. Earlier it was for every user and age bucket, it was creating a group. Now it is creating a group at age bucket level only, right? So again, I'll just come here, and here in the join, I don't need user ID. I can join on the basis of age bucket itself, and this group by is gone. because the data what I'm getting from my CTs is already aggregated at age bucket level. So I don't have to further do a group by here. Hence, I can remove these sum functions also. Because no aggregation is required, I just have to do number manipulation. Pause the video, go through the changes I have done. All I have done is remove the user ID column from my CTs because user ID was only required to join these two tables, correct? And it is not required any further, so I have removed it. By removing it, my aggregation is done at the age bucket level itself. And when I am joining these two CTs, I don't have to do a further level of aggregation, right? It's already at the age bucket. So if this is clear, let me run the code. And the output already looks correct. So I will just go ahead and submit it. And it is also accepted, right? So, but as I said earlier, two things I mentioned, that you are doing a lot of group by. So we were able to remove one group by instead of 3. Now we just have 2 in the group by. But I also mentioned one more optimization which I can see as part of 4th step, revisit the output, is I'm joining the same 2 tables multiple times. Here and here I'm joining, and then here and here I'm joining, right? So I believe we can further optimize it. And as I said earlier, the answer is correct, the query is correct. Nobody can say that your query is wrong, but they can definitely ask you that can you further optimize it. So if you are a fresher coming straight from college and you are trying to solve this SQL query, if you solve it with iteration 1, if you solve it with iteration 2, if you have an interviewer like me, I will move to the next question. I will definitely ask that can you further optimize it? But if you can't, we'll move to the next question. And for me, it's a pass, right? I will not mark that SQL as fail for you. It's a pass because you are able to solve it. But if you are somebody who is 6 years, 7 years experience into SQL, then I expect you to, at least from iteration 1, you should be able to come to iteration 2, right? So, and if you are somebody who is like 10 years of experience, I want you to further optimize it because if the tables are very big, right? And then joining the same table 2 times is not a very efficient manner. Unless you are joining an index, it's very quick and all those things may come into the picture. But ideally, you should be joining 2 tables once and then use your output for your final result set. You should not be joining the tables multiple times unless and until there is a clear business use case for it. Alright, so in iteration 3, we'll go back to the keyword sheet and we can see that there is an option aggregate comparison. We are going to rewrite this query and we'll make sure that we are joining these 2 tables just once and not multiple times. What I will do is I will pick this, and this time instead of picking just send, what I will do is I will also bring open. So what has happened now is I am getting all the records from this table where activity type in send and open, and then this table will come as is, and I'm joining these 2 tables on the basis of user ID. So all the records for send and open, I'm joining these 2 tables just once. I don't have to join this 2 table again, right? And what I will do is all the required columns, I will fetch that. So select dt2.age bucket. And for comparison aggregation, we generally use some case statement along with the group by. So I'm going to use the same thing here, some case when activity type equal to open. Then I will consider the time spent, else I'll say 0, send as open time total. I will query the same again, and this time I'll just change it to send. I will call it as send time total from this. So what I have done is, with the experience and with the SQL breakdown structure sheet, I already know that some case when along with the group by comes whenever there is an aggregation comparison. So here we want to compare these 2. So I'm using a sum with a case statement here. I have open time and send time total here. Since I'm using the sum function, which is an aggregate function, I have to use non-aggregate columns in the group by. I have seen so many times people write group by queries, but they don't add all the non-aggregate columns in the group by, which is wrong. And this looks good to me. This query looks good to me. So now only this number manipulation is pending, where I have to calculate the percentage. I already have the time total. So what I will do is, I can do it right here also, but for the sake of simplicity, and I know today's generation prefers to create CTE for everything, so I'll also create a CTE here. So I have this data. What I will do is, I'll just run this query once so that you can also see how the data looks like. So you see age bucket, time. So I already have total time, but I have to calculate percentage, which is this divided by total. So again, I will do the same thing here. Select CTE. Let's call it as CTE1. So I will do CTE1 dot age bucket, which is my first column. And then I will do the manipulation. So what I will do is, I'll just copy it from here. Right, and this time I will use send time total plus but time as 7%. I'll copy this, and this time I'll make it runtime as open percentage. SS, obviously there is no SS here. I will remove these. It is on CTE1. I have to add open time here and open time here. Yeah. So let me run the query, and I can see the output looks good. I am ready to submit it, and it is accepted, right? So you see here, we started with 3 groups by and 2 times join for the same table, and we revisited the output, optimize our query, and we came to iteration 2, where in iteration 2 we were able to reduce one group by identifying the column which is not required in the output and removing it as soon as it was not required from the group by. So from 3 group by, I'll write it here. So we have 3 group by and 2 times join. We further optimized it to 2 group by and 2 times joins, and we further came down to 1 group by and 1 join. So yeah, so this query is much more optimized as per me, and if you are writing this query, I will not ask you to further optimize it. I will just move to the next question. This question is passed from my side. So yeah, I hope the way I broke down this SQL problem and solved it help you. The sheets required for SQL Pattern System, the maze approach, and the SQL Breakdown Structure is available. You can download it for free, you can use it. Keep practicing SQL. If you have any problems, just let me know. I'll see how can I help you. Thanks a lot for watching this video. If you're not subscribed, just go ahead, subscribe. I'm working very hard to come up with these videos. I spend a lot of time. So a like or a subscribe really helps.